Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and in this supplemental tutorial for Chapter 15, we're going to be taking a deeper look at the proprietary Cisco Hot Standby Router Protocol, HSRP. And specifically, we're going to look at how we could configure load balancing across multiple HSRP routers with Multigroup HSRP. Now, in this first supplemental tutorial, we're going to be taking a look at this from doing it with the same VLAN. In other words, the VLAN is VLAN 10, and we're going to split it so half of the nodes in VLAN 10 are using router 1, and the other half of the nodes are using router 3. Because remember, one of the major challenges that we have when we're setting up HSRP is that all of the traffic is coming to the active node. And specifically from activity 15.2.3, you'll remember that we set router 1 up as the primary or the active HSRP speaker, and router 3 was just kind of standing by waiting for something to happen. So how can we take advantage of router 3, its CPU, resources, throughput, bandwidth, etc.? Well, we can load balance the clients in a single VLAN, and that's one approach to doing multi-group HSRP. In the next supplemental video tutorial, I'll be covering multi-group HSRP if we have multiple VLANs. So let's jump into the Cisco Modeling Labs interface. And as you can see, we've got an architecture that is very similar to Packet Tracer 15.2.3, where we have PCA and we have PCB, and we have a simulated internet address up here on router 2 that is simply a loopback address, 209.165.200.201. So the first thing that we want to do is log into PCA with the username Cisco and the password of Cisco, and let's see, can we ping 209.165.200.201? Can I reach that internet address that we're simulating with that loopback? And absolutely we can, so good news there. And let's check with PCB. Now, we're not running HSRP in the environment right now. That's what we're going to be doing here. So Cisco to get logged in. And let's see if I can ping, not pong, but ping 209.165.200.201. So fantastic. Both of these nodes can get out to the internet, so to speak here. But what happens if I was to say trace route to the 209.165.200.201? And we'll kick that off on PCB, and let's come over here to PCA and do the same thing by saying trace route 209.165.200.201. So we'll swing back over here. And as you can see, the first hop that gets taken here by PCB, which is an Ubuntu Linux workstation, or it's an Alpine distribution Linux workstation, you can see here that it's 192.168.10.3. So we're going to router 3 because on PCB, we have router 3 hard-coded as the next, the default gateway. So if I was to cat the etc network and interfaces file, you can see that the gateway IP here is 10.3. Now, very similar to what we saw in the previous activity, where we're hard coding the default gateway onto the PCs and putting in the IP address that resides on the physical interface for both router 1 and router 3 respectively. So PCA is using the physical interface IP on router 1. PCB is using the physical interface IP on router 3. And we talked about why with HSRP we would want to deploy that, and that's if the interface on router 1 or router 3 were to go down. So here's how we can load balance the traffic with redundancy, because you might be asking yourself, well, if you have 100 PCs hanging off over here, off of this switch, and they're all in VLAN 10, and then you've got another 100 PCs over here in VLAN 10. Why don't we just set these ones up to go to the physical IP, and then these ones up to go to the router 3 physical IP. And it's for that same reason that we explained in the 15.2.3 activity, is that if that interface goes down, all 101 hosts over here are done. They no longer have connectivity to their first hop, which is the default router, and so then they're down. So we want to deploy Multigroup HSRP, which is going to be the creation of 2 HSRP groups. One will service the left-hand side of our diagram here, which is the PCA side. We'll say that'll be the half of the network. And then the PCB side would be the other half of the network, but it's all the same VLAN. So let's see what that looks like. Again, HSRP was unconfigured from the previous video we worked on. So let's come on to router 1 and let's get these multiple groups set up and ready to go. So we're still working with interface do show run interface gigabit Ethernet 03 here. And so what I'm going to do is go into Internet Gigabit Ethernet 03, and here's what we're going to do. So I'm going to match the HSRP group number with the last octet of the default gateway address, because we're going to be creating 2 virtual IPs. Again, one virtual IP will be referenced by PCA and its colleagues, its peers, and then PCB, everybody on the right-hand side, is going to be using a different HSRP default gateway virtual address. So let's go ahead and say standby version 2. Again, we're going to be switching to version 2 because we still have our debugs on here. So we say standby version 2, and then we're going to go ahead and say standby. Now, let's go ahead and use 250. So standby 250 is the group number. That is the HSRP group number for the hosts on PCA side. Again, there's only one host with it's PCA, but we're just kind of pretending that there's a whole bunch of hosts over there with PCA. They're all going to be using this and router 1 as their primary. So standby 250, we'll say IP is going to be 192.168.10.250. Now, we're going to go ahead and say standby 250 priority, and I'm going to set it to 200. And then we're going to say standby 250 preempt. Now, if you remember from the previous activity that we were working on, when we were working with HSRP, the preempt command is very important, because what that means is if for whatever reason the HSRP were to go down on router 1, or I should say the interface were to go down on router 1 to the switch, we would have it fail over to router 3, but we want it to come back. We want it to come back to router 1, so that's why we've got the preempt on router 1. So let's go ahead and say do show run interface gigabit Ethernet 03, and what do we have? So there's our configuration for what would be the default gateway IP of 192.168.10.250. So we're on the same interface. Let's go ahead and configure the standby 251, and that'll be PCB and its peers, 251 IP 192.168.10.251. Now, you're probably wondering, well, how is this going to work with the default gateway? And this is why the heavy lifting in the multi-group HSRP within the same VLAN, the heavy lifting is done by your system admins, because they're the ones that are either going to have to hard code or with the DHCP settings for the PCs to make sure that they're splitting these up evenly. All right, I'm going to say do you all. I'm going to turn debugs off for right now, and do show run int gig 03. Let's make sure that command took, because the debugs kicked off right away. All right, so you can see there we've got the standby IP command. Now, I'm not going to put the priority command in here, because this would be the backup, the standby node for PCB and his buddies. Because what we want is we want PCB to use router 3 as its active node, and we want PCA to use router 1 as its active node. And then router 3 will be the standby for PCA and all of his buddies on this side. And router 1 would be the standby for PCB and all of his buddies on this side. So let's go ahead and continue here. And that's all we're going to do on the gig 03 interface, because we have everything that we want in terms of the standby 250 and the standby 251. So let's go ahead here and let's say end. And then let's say write mem, and we'll come over here to router 3, and we'll knock out the configuration on router 3. So let's first take a look, show run int gig 03. And what do we see here? All right, so that looks good. So let's get into global config int gig 03, and we're going to say standby, version 2. And then we're going to say standby, and let's actually turn the debugs off here, do you all, so that we can see what we're doing. And so then we're going to say standby. Now, this is going to be the primary for the group 251. This is going to be the active HSRP speaker. So IP 192.168.10.251. We're going to say standby 251 priority is going to be 200, because when the election takes place here, we want router 3 to be the active node for group 251. And then we're going to say standby 251 preempt, because this is the primary. And then we can knock out standby and take a look right there. We drop the preempt command in there, and now that is the active node for group 251. So PCB and all the PCs that are on the right-hand side, or that would be on the right-hand side. And then let's go ahead and say standby 250 and IP 192.168.10.250. Now, you'll notice I'm not putting the standby 250 preempt command in here. I'm not putting the standby 250 priority command in here, because again, this is our backup node. Now, let's see what happens. We're going to induce some failures here. So let's save our config. And let's see what we've got when we say show standby, right? And you can see group 250 went to standby. So show standby. And we've got a lot because we've got two groups. So how about this? How about a show standby brief? Might be a little better. Okay, so the preempt is off. So my question to you, you can see that the state is standby. Do we need to configure preemption on the standby node when we only have two? Or is it good enough that it's configured on the primary, the active node? Think it through. If the active node goes down, do I have to have the preempt here in order for router 3 to pick up and become active? Think about that, because that's going to come up here as we work our way through, because that's a great question, and you'll see this a lot in configuration of HSRP as to whether preempt shows up on both the active and the standby, or if it's just on one side. So here's my virtual IP. So now what we need to do is let's come on to PCA, and let's go ahead, and we're going to have to cd into etc network and sudo vi interfaces. And I'm going to use the vi editor. And we're going to come down here now, and let's put in the password first. So now I'm going to come down here. So for PCA, what did we say? If we come back over here to router 1, and if we were to go ahead, it's going to be group 250, show standby, brief. I was thinking about something else there for a second. So you can see that we're going to use 250, right? Because we are the primary active. So 250 is going to be for PCA. And again, router 1 is the active. So let's come over here and let's go ahead and set this up as 250. And we'll save this file. Now, is that enough? Let me give this a try. Let's say ping 192.168.10.250. And as you can see there, we've got connectivity there. However, let me do a Control-C. Can I ping out to that simulated internet address of 209.165.200.201? And I can. Now, if you can't, what you might have to do is you may have to restart the networking service, right? So, and we'll see if that happens over on PCB. But for right now, it is working. In fact, if I was to say trace route to the 209.165.200.201, where should we go? We should jump to router 1, and we do, because that is the primary HSRP router. That is the virtual IP and MAC address that is being advertised out by router 1 as the primary for PCA and any PCs over on this side. Again, we're all in the same VLAN here, so I'm divvying things up 50-50 in the same VLAN. All right, now let's come over here to PCB. And we know that PCB, and if we were to pull this up, we had the show standby brief where it shows me that 251 is going to be the active default gateway that we would want to use here. So let's say sudo, and actually let's get into cd/etc network and sudo vi interfaces. Cisco's my password. We'll come down here, get rid of this default gateway statement, which hard codes us to the physical interface, and we'll say 251. And so now all the PCs on the left will have their default gateway configured to be 192.168.10.250. Everyone on the right, PCB, will have their default gateway configured to 192.168.10.251. And again, we're doing multi-group HSRP. We've got 2 groups configured on each router. In fact, let's pull that up and take another look. Show run interface gigabit Ethernet 03. So there are the 2 groups configured, 250 and 251. And the same thing is true here. Show run int GI03. And it's just that the primary, the active HSRP speaker is 250 over here and 251 over here. So now let's go back to PCB and let's take a look. Can I ping 192.168.10.251? And I can. Can I get out to the internet, that simulated address, the 209.165.200.201? And I can. Let's trace, let's do a Control U there. Let's say trace route out to the 209.165.200.201. And where should we go? We should go to router 3. And we do. But we're not going to router 3 based on the default gateway setting of PCB pointing to 10.3. It's pointing to the HSRP group virtual IP and MAC for group 251. How can we prove that? Let's come down to the switch again here. We get on the switch and we can say show MAC address table, and let's take a look. And actually, this might be a little difficult to sort out here, to be honest. Now, we'll be able to pick off, and so actually it's probably not. So here we go. So we can kind of back our way into this here. So here are the hexadecimal values for 251. And the reason I know that that is the virtual MAC for 251 is because it says to send traffic with that layer 2 MAC address out gig 03, which is up to router 3. And where does it say to send traffic? For the virtual MAC address, Fox 0, Fox Alpha. And remember, A has a value of 10 and decimal, B of 11, and it says to send it over port channel 1, which is across that link right there. And why would it be sending for the HSRP group 250 over here? Because again, that's router 1 is the active HSRP speaker for 250. So now let's simulate some failures. And the first failure that we're going to simulate is on router 1. So we're going to take down the physical interface here on router 1, gigabit Ethernet 03. And so here's what gigabit Ethernet 03 looks like right now. Now, again, if I was to say show standby brief, you can see that gig 03 on this router, the local router, we are the active HSRP speaker. There is the standby. Now remember, in the backup group configuration, the backup HSRP group configuration. And you can see it here on gig 03 for 251. Is there a preempt command? Because again, it's already the standby. So do I need to have it set to preempt, or is it going to simply assume the role of the standby? And then on the primary side, which would be the router 3 side, that's where we need the preempt statement. Just like here, we have our priority and our preempt statements. So let's go ahead and let's kick off a continuous ping here, because PCA would be the PC that's going to be impacted. So I'm going to say ping 209.165.200.201. Now that is that simulated internet IP address. You can see we're able to ping that, no worries. Now let's come over here to router 1. Let's dive into global config into interface gig 03, and let's shut that interface down. We're going to scramble here over to router 3, where we're going to say show standby brief. Now, as you can see, the preempt flag's not set, but it shows that I'm the active. So I became the active anyway. And if that's true, we shouldn't be dropping any packets. And take a look at that. Absolutely seamless transition for PCA to start using router 3. So it was using router 1 as its default gateway because that is the active HSRP speaker for group 250. And then we had a failure on router 1 where that interface went down, and now all traffic automagically switches over here to router 3 because it has assumed the active role for that group. So the question is, do you have to have a preempt statement on the standby side? And the answer is no. The standby took over by itself. The preempt statement, we're going to need that on the primary side, like we showed in the previous video, because when router 1 comes back up, we want router 1, obviously, right? Because that is closest, group 250 is closest to PCA and all the PCs that would be plugged in on the left-hand side over here. That's where we want the traffic to come back through. We don't want the traffic to continue to sort of, I don't want to use the term trombone, but to maybe traverse those two switches and then to continue to come this way even though router 1 is back up. That's an extra hop to switch number 2. We're also competing with all the traffic from PCB and his other PCs over here, and it defeats the purpose of the load balancing inside the same VLAN that we're trying to accomplish. So let's go ahead. Let's bring router 3's primary interface back online and let's see if it will preempt for group 250 and take back over. And take a look at how quickly that happened. And let's see, are we dropping packets? Are we stuck? We're not. And if you look here, you can see the difference was about 2 milliseconds in time. If I was to do a Control C, the switchover came right around there, and you can see we were about 2 extra milliseconds to get over here to switch 2 and then up to router 3, and then I did the switch back again on average there, and then immediately it dropped down into the 8 to 9 millisecond range. And obviously we've got an outlier here with 11, but you get the idea. So that is where we want the traffic coming. Let's confirm that. What if I was to say trace route to the 209.165.200.201? Is traffic now going to the 192.168.10.1 router 1 IP? And it is. So let's check PCB out. Let's see what happens over here. So let's go ahead and trace route out to the 209.165.200.201. And where should we go? We should go to router 3, the 192.168.10.3. And we do. In fact, as I showed you earlier, if you look at the switch's MAC address tables, we can see here are the 2 virtual MAC addresses for 250, group 250, and group 251 respectively. And again, 251 says go right up gig 3 to get to router 3. But for 250, it says cross the port channel link to come over here, right? And that's because it's the backup for 250. Or, I'm sorry, the primary for 250 would be to come across that port channel, and the primary for 251 is to use that gig interface. So let's go ahead on PCB here, and let's see if I can ping 209.165.200.201. And we can. So now let's come up here to router 3, and let's wreak some havoc up here. If I say show standby brief, you can see we are the active, and the preempt config is set for router 3. But what happens if I go into global config int gig 03 and shut that interface down? Let's come to PCB here. And sometimes these nodes, these Ubuntu nodes, can be a little testy, and they don't like when things get switched around. And so that's what we're kind of seeing here. So let me do this. Let's do a Control-C, and let's go ahead and do a sudo, what is it, service, and then networking, and restart. All right, we'll put in Cisco as the password. All right, so let's see if that is able to sort things out. So now you're probably not going to have to do that every single time, but we did have to do it there. Probably a leftover. We probably should have done that after we changed the file the first time. And so as you can see, the pings are working. What if I was to say trace route over to the 209.165.200.201? We should be going across the port channel to the backup the standby, who is now the active, router 1, and there's router 1's IP. How else can we confirm that? Well, let's see. HSRP group 251, show MAC address table. Where is that traffic being forwarded? And there is the virtual MAC address, and it says to go across the port channel now, because now router 1, the standby for group 251, is the active for 251, and it is advertising the virtual IP and the virtual MAC address for group 251. Now, it's also the primary and the active for 250. And so here we've seen how you can approach multi-group HSRP inside the same VLAN. And again, the heavy lifting is on the system side, where this half of the systems over here with PCA need to point to one virtual default gateway address for group 250. And over here on PCB, and all the PCs that would be over here, would need to be pointing to the virtual IP address as their default gateway for group 251. And we also saw that the preempt statement, and let's swing this back here on router 3, let's say no shut. Does router 3 preempt and take back over control? And you saw it right there for group 251. Take a look. Went from listening to active right away. And so if I was to come back to PCB here and we were to kick off another trace route, what should we see? We are going to see that it went to the 10.3 for PC, I'm sorry, not for PC3, for router 3 on its first hop. And there it is, right? And so that is multi-group HSRP divvying up hosts in the same VLAN. Now, could you do this for multiple VLANs? You absolutely can, and that is what we're going to be taking a look at in the next video. So again, hopefully this gives you an idea as to how multi-group HSRP works within the same VLAN if you only had a single VLAN. And now let's take a look at what it looks like when we have multiple VLANs. All right, thanks so much for watching, and I hope to see you in the next video.